Bonjour, bienvenue tout le monde. As you can see, my French is not really that good, so I will continue in English. Although my native language is Spanish, I'm given to understand that most of you took Spanish courses earlier in your career, so yeah, I guess I will say if I continue with English. Please feel free to stop me at any time. If you got any questions, we got 45 minutes, and let's make the most out of that time. So as you can see on the title of this presentation, what we actually want you to feel when you're working with your Java projects or Objective-C projects, and you will see that in a moment, we want you to feel like this. To have fun, to be able to be productive, to be able to do the task at hand without having to worry, is the build tool doing the right thing for me? Do I have to go back and touch on that terrible, horrible XML file in order to do the job that I need to do today? All right? So quickly about me, my name is Almiray. I come from Mexico. I currently work for this company called Canoe. It's a company in Switzerland when we do all kinds of interesting stuff. And we work with many technologies. And Gradle and Maven are just a few of the technologies that we use in our daily work. And that's one of the reasons why I'm here, because we enjoy working with these technologies so much that we gain some experience on those things, and we want to share that knowledge and share that experience. All right, so the topic of today is Gradle and Maven. So quick poll, how many of you, and pretty much most of you, use Maven already today? Almost the whole room. How many of you use Gradle already? Like 25%. Okay, so my goal today is to try to convince you to give Gradle a try. Some of you might switch immediately, some of you might say, oh, I don't like it for some whatever reason. We'll see. Okay, so Gradle is a build tool, just like Maven. And as a matter of fact, there are more than just a couple of build tools that you find out there to build Java projects. Anybody ever used Maven 1? Just a few hands, wow. When I ask this question, almost nobody remembers Maven 1. And of course, people know Ant. Anybody still using Ant? Oh my God, really? Builder? Nobody. Raven? Aha, nobody. Good. Okay, so Gradle is a build tool, and it builds on top of the power of conventions that Maven gave us, but also has a much better, I would say, it's a much better DSL. And disclaimer, I'm a member of the Groovy development team, so I definitely love the Groovy. And what is great about, so at least we got a little bit about in the history of Java-based build tools. In the beginning, so this was back in 96, 95, we didn't have anything. We only had Make. And the creators of the Tomcat project needed something to build a project in different platforms. So Java is compiled once, run anywhere? Right. How do you compile it in different platforms? So they had a task to build something on top of Make, and they said, no, that's not going to work. Let's build Ant. Great. So you know what's the difference with Ant and Maven? The creator of Ant apologized for using XML for the declarative DSL. That is true. So for a while, Ant was great. It gave us a lot of power, a lot of capabilities to define exactly what you want to do. The problem is that once you have defined a particular build file, when you go to the next project, what do? Copy and paste, and actually copy and pray that what you have in your second project is going to work exactly what you need to do. And so after a while, a new project emerged in the Apache community, and that was Maven 1. Maven 1 took a lot of inspiration from Ant and allowed you to define everything that you needed using an XML-based language. If you program in XML, let me tell you, something is terribly going wrong. But it was good. Actually, I like Maven 1 because it gave you a lot of possibilities, a lot of power, but also gave you conventions. So if you follow the project conventions, then the configuration will just shrink. It will be much easier. But because everything was done declaratively with XML, you did have for loops and conditionals in XMLs. So then came Maven 2, and they gave us plugins, and they gave us dependency download management, and many other nice features. But we also got the Maven way. If you follow the happy path, everything works correctly. We know this, right? But if you do not, things will go sour. So Gradle came in later and said, we really like the conventions. We really like the power of configuration. But we don't like to repeat ourselves. We would like to do things in a slightly better way, and we would like to change the DSL. Instead of using XML, why don't we use a real programming language? There were many choices they could have taken, and they decided to go with the Groovy language just because at the time, this was back in 2007, it was the best option that they could have. For those of you that may be thinking, why would they go with JavaScript? If you want to script Java with JavaScript, let me tell you, that is not an option. No, really, don't do that. No, there are better choices. Anyway, so let's continue. So Gradle has the power of Maven conventions. So if you know the Maven conventions by heart, then switching to a Gradle project is quite easy. Also, it's very expressive because instead of using XML as the DSL, and I know there are great tools out there that will give you code completion with XML, you know this, you have seen it in the past. Eventually, you just start to see lots and lots of characters in your screen, but it's little content that actually matters of what you're writing in the DSL. In the case of Gradle, they chose Groovy, which condenses the amount of content and the amount of information versus the amount of syntax that you need to write in order to get the work done. It's also extensible. This is also true from Maven. We got modules, we got plugins in Gradle. You can also extend the capabilities of the project using plugins. It's very productive because, as it turns out, the speed of invocation of a Gradle build is actually much faster than the one from Maven and this is one key aspect that the people behind the project are actively looking at. Also, disclaimer, I have no relationships directly whatsoever with Sonatype or Gradle Inc., the companies behind both projects. So what I'm saying is exactly just my personal experience. And it's very convenient. As a matter of fact, this particular feature called the Gradle wrapper has been so useful in getting Gradle across organizations that the Maven project is copying this. So what is the Gradle wrapper? It's just a tiny set of scripts and a tiny jar that allows you to fix the Gradle version that can be used with a particular project. So when you run your build on a CI environment, you don't have to have Gradle pre-installed on that system. You simply execute the wrapper, which will download Gradle from a predefined location, which may be outside on the web, or it could be inside your organization, so you can control exactly which artifacts, which plugins, which versions, everything, up to your needs. So now, it's much easier to provision a Gradle project in any CI environment. If you want to do this, it doesn't matter which CI server that you want to choose. If you want to run Maven on such CI servers, you have to ask IT department to provision the Maven. How many minutes does it take? For some people, it takes weeks. But in the case of Gradle, just add the wrapper, 5 minutes later, you push, done, everything is running. It's as easy as that. And that's the reason why Maven is also going with this direction, because it makes sense. So why do we want to do things? Well, this is a graph of a report that the company, Zero Turnaround, the authors of Rebel Labs did, I think it's close to 3 years ago. So the numbers should be different now. They ask a lot of developers what are the tools of choice that they are using, and in terms of build tools, these were the answers. So you see at the time, Maven into 2010, it had half of the market, and it kept growing and growing, apparently. Gradle didn't have that many market share at the time because this is the times before it went 1.0. And then notice that how quickly it rises up. Now, 1 year later after this, Google decided to switch its Android development from Ant to Gradle. So I definitely can say that this number is much higher now, just because every Android developer out there is now using Gradle. So in the case, and the other alternative is to use Ant and Ivy. If you ever use Ant and Ivy, Ivy allows you to download dependencies, kind of have dependency management like in Maven. Sadly, Ivy is a dead project. So if you're still working with Ant and Ivy, I will certainly recommend you to switch to one of these two, Maven and Gradle, because they have much better maintenance. In case of some of the features that were also coming from this survey, let's see, in the case of the learning curve, they say that Maven is easy to understand. As a matter of fact, this is certainly quite easy. It's just a handful of phases and life cycles. How do you configure a plugin? How do you understand XML? There's not so much of a problem. In the case of Gradle, they said, because you have to learn a new language, which happens to be the Groovy language, then things start to get a little bit scarier. Now, how many of you use Groovy already as a language? Just a few hands. But how many of you use Java on your daily work? Mostly all of you. If you didn't know, just take out the semicolons from Java, or even better, just rename .java into .groovy, use the Groovy compiler, and I can guarantee 98% of the times the code is going to work, because that's how close the Groovy language is to the Java language. But if this is where the only thing that the Groovy language will give you, what's the point? Of course, you can write Groovy in a more idiomatic way, and you can switch from a very Groovyish syntax to a very Java-ish syntax as you feel comfortable. This is one of the key features that allows Groovy to work seamlessly with Java, which no other JVM language can do. So, all of you that raise your hand that use Java, you can leave this talk by knowing you already got another language under your belt, and that is the Groovy language. All of you are now Groovy developers. Trust me, this is true. So, build speed. Maven is okay. They responded that Gradle was actually a little less. That Maven is actually much less now. The speed improvements that the Gradle people are doing, they are amazing. In terms of complexity, again, Maven is that simple. Gradle is a bit higher because additional language. Well, now you know that's not actually true. In terms of plugins, Maven has had a head start because it's an older and more mature project. So there are much more plugins out there. But the Gradle community has created much more plugins since this survey came out. So I will say the numbers are close now. And Ant, well, Ant is what it is. In terms of community and documentation, here is where you will find that Gradle is definitely the winner. The documentation that you find in the official site is definitely top-notch. It's much better. I kid you not. When I created my blog 10 years ago, I had a silly entry on one of my open source projects because I created a Maven-based site for this project, and I wanted to put a couple of images on the left sidebar. Do you know how to do this? Well, it's just adding a couple of images to an HTML, isn't it? Well, it's not as easy as you will think. You have to know Doxia. You have to know a few things about how the Maven documentation generator works. It turns out that the blog post I wrote in order to tell how to do things is the most popular one on my blog. Because it's not officially documented. Whereas in the case of Gradle, there are many things that you'll find in the official documentation. Finally, developer tool integration. This was true 3 years ago. Now it's much better. Maven has excellent support in any IDE that you pick, especially apparently NetBeans is the Maven-based IDE. Anybody here using Eclipse? Guys, switch to something else, please. The Gradle support for Eclipse is now much better. There's an official Gradle plugin called BizShip that has good integration with Eclipse, but if you want to use something that works a little bit much better, use IntelliJ. Seriously. Well, The Gradle company, as I said, there is a company behind Maven called Sonatype, which are the ones behind the Maven Central repository where we find all our artifacts. Well, there is a company behind Gradle called Gradle Inc., and these are just a few of the key customers they have. So if these guys, these companies that are big, have switched to a different build tool, it's probably that your companies can also do the switch if need be. Now, some of the reasons why I personally have chosen to use Gradle. I use Maven 1, as I said, I use Ant and Maven 1 for 3 or so years. I used Maven for 6 years. And since I discovered Gradle, I said, I thought to myself, maybe this thing is a bit better. And turns out that most of the times, Gradle has been a much better experience for me than just going back to Maven. So we got caching of task inputs and outputs. Now, you guys let me know if this is true, if this has happened to you. You have a project and you want to build a site out of that. You have tests and you also have code coverage. How many of you use Cobertura? Few hands. How many of you use Jacoco? Much better, more hands. So this is what happens when you configure Cobertura in your Maven project and you have some tests. You do Maven side and then goes through compile the sources, process resources, run the test, instrument the test, run the instrumented test for code coverage, then start generating the Java docs, and run the coverage again. This is because the Cobertura plugin is broken. If you use Jacoco, code coverage is computed just once. Another reason to switch to Jacoco, and it gives you much better numbers. And then it generates the site, right? Everything is fine and dandy. You notice you made an error on the documentation sources. So you change the sources and do Maven site again. What happens? Goes through the compilation phase again, goes to test, code coverage, Java doc, runs Cobertura again, and generate the site, right? So when you do this with Gradle, this is not what happens, because Gradle knows what are the inputs and the outputs of a particular task. So if any of those inputs did not change, it's very likely that if you already had the output, then the output will not change. So it caches that information. So when you try to generate a documentation site out of sources in Gradle, the second time you run the site generation, or in this case, very likely it's going to be ASCII doc based, then it doesn't compile the sources because there's nothing to compile. It doesn't run the test, nothing to be changed here. It only generates what needs to be generated. This case is going to be just a documentation. Now, it has a much richer configurable lifecycle. How many phases do you have in Maven? 20. If you add the site plugin, 25. Can you have more? No. Can you have less? No. In Gradle, how many phases there are? It all depends. It all depends on which plugins you have added, because you can have more phases or less phases. You can override pretty much anything. The object model behind the Gradle project is much richer and much more extensible. This is one of the other key origin features of the Gradle project. They wanted to make sure that you could extend the build in such a way that you are the ones in charge. Whereas in the Maven way, if you follow the Maven way, everything's fine. If you don't follow it, I don't know, everything could happen. So is your project in charge, or is the build tool in charge? That is the question. The Gradle wrapper I already mentioned, but there's also this thing called the Gradle daemon. The next thing is true for any build tool of your choice that runs on top of the JVM. Because it's a Java application anyway, Maven and Gradle, Builder, all of those, you have to start a JVM in order to run the build. Start the JVM, process the build file, run the build. What happens with the JVM once you're finished? It's gone, right? So the next time you kickstart a build, what happens? Start a new JVM, so you pay the price for that, run, then kill the JVM every single time. Wouldn't it be better if we were able to have a background JVM so that the next time you make a build, the JVM is already hot and has all your classes, everything that is needed for the build itself is already there. So your next build is going to be faster and faster and faster. Wouldn't that be great? Well, that's exactly the Gradle daemon. And this is another feature that Maven is copying from Gradle. So there's cross-pollination. Multi-project builds. Maven was not designed to handle and tackle multi-project builds. We had the Reactor plugin in Maven 2, and then Maven 3 had a much better support for that. Let me tell you that Gradle has been designed from the start to support multi-projects. Now, I would say that handling multi-project, and I have a demo for that, and I will show you, it's much easier in Gradle than in Maven. There are a few things, when you have a big multi-project build, things can get messy, regardless of the build tool. But it's much easier to get started in the Gradle way. Plugin development is much more intuitive. Anybody here written their own Maven plugin, a Mojo? A few hands. Did you like the experience? Aha, some nervous laughing. Yes, so it is what it is. But I have written a couple of Maven plugins, and yeah, I didn't like much of the experience. I have written quite a good number of Gradle plugins, and let me tell you, it's so easy and so addictive that the moment that you start writing a plugin, you start to find places in your custom builds where you can say, oh, I can do this with a simple Groovy script, or I can turn this into a Gradle plugin that can be reused across many other of my own projects. And it's actually quite simple. And finally, well, of course, documentation is much better. So how can we do things? How do you install Maven? By hand? Do you download a zip file and then configure environment variable, right? And when the next version of Maven comes in, what do? To download the next zip file and then configure the environment variable? Well, Gradle is installable in the same way. Just download the official distribution, configure the environment variable, then you're done. Wow. Can we do better? Yes, we can. SDK man. It works for both Gradle, Maven, and many other tools. It's a set of scripts that works in major platforms. Yes, even on Windows. If you're running Windows, switch to a better operating system. Anyway, you can install these tools using SDK man, and that's as easy as just installing the script and then just install Gradle or SDK install Maven. What is great about SDK man is that if you need to switch to a newer version, then you simply say SDK install whatever the name of the candidate, Gradle, Maven, Groovy, and Scala SVT, and then the name of the version. If you need to roll back to a different version, just simply say SDK use, name of the candidate, name of the version, number of the version, that's it. You can even have two different versions in two different shells at the same time. That's great. Okay, say that you got Gradle installed. Perfect. Now, this is a very trivial project that we're going to go through. Say this is your production sources. This will be a main class that has a main method, and then we have some test sources. At the top, we got the Maven build file, pom.xml. We know this by heart. This is the default name and the only name that you can have, so that will be picked up automatically. And in the case of Gradle, you have a file called build.gradle. This is the default one. There are ways for you to change this if you want to do it. Anyway, what I'm going to show next is the minimum set of instructions in a Maven build file in order to compile, run, package, and test this project. The amount of blue versus the amount of black is important. What is in blue color, you can see it at the back, that is the real content. Those are the things that are specific to the project. Everything else is just there to please the DSL and the build tool. It's quite a lot of black, isn't it? So what if I want to have the same behavior in a Gradle build? Notice the amount of black versus blue. Much less black, isn't it? So let me go through it. By default in Gradle, Gradle doesn't know anything about Java projects. Maven does. Maven is built on top of Java in order to handle Java projects, whereas Gradle is built on top of Java to handle projects, wherever they may be. So we had to tell Gradle, we're going to use Java. It's okay. The Java conventions apply to this project. We also want to generate a POM file out of this project because by default, it doesn't know anything about Maven conventions in terms of generating a POM file. Good. Now we specify the group ID and the version ID. What about the artifact ID? In Maven, we had to specify it, what we done in Gradle. Again, conventions is the name of the folder or the name of the project. If you want to have a different name, just put it there. But in the case of Maven, you got the name on the folder and you got the name on the metadata, the POM file. Why the duplication? Because we also have no idea what Maven could be by default in Gradle, we have to tell it from which repositories we can download dependencies. Maven has two default repositories that are always available, Maven Central and Maven Local. In the case of Gradle, you have to tell explicitly which repositories you want. It could be Maven Central or Maven Local, or in which case you can also use JCenter, which is a superset of Maven Central and contains much more artifacts than Maven Central. And finally, we specify the, the unit dependency. Now, notice the name is called test compile. Let's go back to Maven. It's called just test. Question for you. How many scopes are there in Maven? We got compile, runtime, test, provided, and system. No more, just 5. So with these 5, can you tell me how do you define a dependency that should be available for running tests only, for not compiling the test? Can we use compile? No. Can we use runtime? No. Can we use system provided? No. So there's only test. But this test is compiled also. What we can do in Gradle is explicitly defines you can have compile only, which are kind of like similar to provided scope, or you can have compile time, which will spill out into runtime, or you can also have runtime only, just like runtime in Maven, we can also have test runtime scope. And if these scopes are not enough for you, let me tell you that you can create new scopes. In Gradle, these things are called configurations. You can define as many as you want. You can mix them and match them and do exactly what you need in order to handle the class path as your project needs it. All right, so let's get to the next one. Let's see some scenarios. And some of you might have encountered these problems in the past. I want to create an application that is executable. So there should be some kind of main class somewhere and some entry in the manifest. I want to package that in a jar, but I also want to package all dependencies in a single executable fat jar. And finally, I want to package everything perhaps in a zip so that I can ship to my customer and that she or he can run the application, right? Okay, how do we do things in Maven? Besides what we showed earlier, we just add a new plugin. If we want to run some code, this run execute a main class, then we add the exec Maven plugin and specify the name of the class. Right. If you just check out the project and you want to execute the code, then you know that the target for executing the code is exec Java. If you do Maven exec Java, you will get a failure because there are no compiled classes. So you have to call compile first and then execute Java. This is one particular problem in the exec plugin because it requires the classes, but it doesn't it does not force the compile phase to happen before. So you have to be aware of this. Whereas in the Gradle world, this is all that we have to do. Apply the application plugin, define the main class, and even if you start with a project that you just checked out, just do Gradle run, and this will go through the compile phase, process resources, and finally execute your code. So here the plugins are much more aware of the different phases and the different life cycles that can happen. So let's make this now an executable job. What do we have to do in Maven? Besides the 2 slides that I showed, we had to configure the shade plugin. We had to define a manifest resource transformer so that the manifest of the jar has one entry, the main class. Notice the blue versus the black. And then what this particular plugin is bound to the package phase, one of the 20 phases that we have. And now here comes another thing that many Maven developers do. When we do the package, we skip the test because every time we run package, Maven says you should run the test. There is no way to get around this unless we use a skip test true, right? So what do we need to do in Gradle? Just that. Apply the shadow plugin, follow the same thing, and this is used both by the application plugin and by the shadow plugin. And I'm just adding a new dependency to show, and I will run the demo in just a moment to show that it's exactly what's happening. Now, what I do in Gradle is run a new task. This task, shadow jar, is provided by shadow. Just like in Maven, you can do Maven help of a particular plugin and get the set of tasks that this new plugin adds. In Gradle, there's also a way for you to ask which new tasks are available. Shadow jar will be one of those when the shadow plugin is added. Finally, let's try to condense this into a zip file. We want to have something that looks like this. We want all our jars put in one place and a set of launch scripts that will allow anybody to run the application. Does anybody know how to do this in Maven? Yes, probably use the assembly plugin, right? But that is not enough because the assembly plugin will give you this, but not those. If you just use the assembly plugin, then you have to create those launch scripts by hand. What you can do is apply 2 plugins. The assembly plugin that will put all the files together and the app assembler plugin that generates the launch scripts. So by combining these 2 plugins, you get the behavior. So it's a little bit more of XML that you have to define. In the case of the app assembly plugin, you have to find another XML-based descriptor to say which libraries, which files, and whatnot. So more XML. This is everything that you have to do in Gradle. What? Just the application plugin, because the application plugin, besides running, it also knows how to package things using zip. But if you want to package using tar or RPM or Debian, you will definitely need additional plugins, both for Maven and for Gradle. And these plugins exist for both build tools. So this is everything that you have to do, and then just call another target called this zip. Now, let me show you these examples live, because this is exactly where things get interesting. I have a couple examples, a multi-project build and a simple example, which is what we have so far shown. Let's see if this works. Yeah, we are. So there is the build file for Gradle and the Maven file, and can show that the POM file contains all the information that we've seen so far in the slides. So coordinates. We can also define new properties on a Maven POM file so that I can reuse this value in many places. One place where I use it is when I want to execute the application. Another place is where I package this with the shade plugin. And finally, there's the app assembler plugin in order to condense and generate everything what I need, and some dependencies, right? In the case of Gradle, this is all that I need to have the same behavior. Notice that, again, the amount of code, amount of content versus syntax is much more, is richer than the other way around. So what happens now when I go here and I say Maven clean, should clean everything, fine. And if I do Maven exec Java, remember that the project is clean, it will tell me, I don't know what to do. So I do compile, and then exec Java, and it outputs, hello, DevOps friends. In order to show that it's actually live and I'm not cheating, let's do sample food Java, hello, DevOps friends, this is live. And then we call it again, and then we got a new text. Perfect. I can do Maven package, and I'm going to skip, and there's not a skip the test. Let's see what happens. Oop, we got a failure. It says, we were expecting something else. Nice. Never trust a test you haven't seen fail once. So let's see what happened in the test. We're expecting to see hello world, but we actually have a different text. Okay, change this to that, put it there, run the test again. And remember that what I wanted was just to create a package, but it's running the test. Okay, this is getting silly. Minus the skip tests true. There we go. Now you see that the shade plugin now has generated a new jar. And when we see that in our target directory, here we see the original sample jar, and there is another one. This is just my production code, and this is my production code plus all the dependencies in one single fat jar. Let's see the sizes. And one of them is quite small. That's my original code, and this contains my dependencies. If I look inside that, target, sample, there's our, where is it? There's our production code, and then the rest of the dependencies. In this case, it's just common slang. I can run this because it's executable and say sample, and there we got it. And if I just attempted to run the original one, then it's not set as an executable one. Perfect. Good. Finally, I don't remember exactly what did I need to do here. Oh, I think it's app assemble. Let's do Maven app assemble. I think it's assemble. Does anybody remember? Yeah. Sorry, I should have been prepared before for this one. Assemble, I believe. No. Assembly. I think that the app assembler had something else. Yeah. Well, it's easy. So if you know what was the magic incantation to invoke assembler, then this will generate the right package for you. The problem that you will find is that the jar that it will use in the assembly will be the fat one instead of the original one. So you have duplicate dependencies, one in your production jar and the other plus all the dependencies. Let's see what happens in Gradle. Let's do a Gradle clean. So no cheating. First thing is, I want to run the application, right? So it's just called Gradle run. And notice that it compiles, process the resources, no resources, generate the classes, run. Perfect. What happens if I run it again? Woo! It did not compile things, and it just ran it. And notice that the second build was much faster, and this is without me running the daemon. If I run it again, almost as fast as before. Good. Now I want to package this thing. I said that we had a good number of new tasks available, and there's the one, shadow jar. This will allow me to package the application in a fat jar. So let's do Gradle shadow jar. And let's look inside build, libs, and we got this. I also can generate the regular jar, and then we got two of them. So the first one is the fat jar, and the second one is just the production classes. So with this now, I can do java-jar, build, libs, sample, and make sure that it's the old one, and it executes. And if I want to just use the production jar, it doesn't find it. All right. Finally, what I can do is generate the distribution for this. In the build, we now see a new zip file right there. If I unzip that file, let's change into build distributions, unzip, unzip, there we go. And just invoke from that thing sample. And there we go. And you can see the structure is the one that is generated. And now you may be thinking, is this the production jar or is it the fat jar? Well, the name says it doesn't have dash all over there. So it's very likely that it's going to be just the production jar. And there we go. As easy as that. Okay, let's move into a multi-project build. So I've been told that this multi-project build has two sub-projects, project 1 and project 2. Project 1 contains regular classes, project 2 has a main class, and it also consumes project 1. So in project 2, if I look into the POM file, there is the exec plugin and a dependency to project 1. Project 1 just defines some, actually just a dependency to the parent POM, and the parent POM says, I have 2 modules and a default dependency. Great. If I just checked out the project, I do Maven clean to make sure that nothing is there. Then I change into project 2 and try to do Maven compile exec Java. It doesn't work. Why? Because it cannot find project 1 as a dependency. Okay, so let's go up. I've been told that I can also do the following thing, which is in Maven is -pl, the name of the project, -im, and then the targets I want to execute on that project, right? And it fails because now the exec Java plugin gets confused. So what do we do now? How do we fix this problem? How can I execute project 2 by having project 1 built? Does anybody know? Easiest way, and this is what everybody does, Maven install, right? Because Maven cannot consume dependencies unless they're available on a repository. So what we're using is pushing our dependencies, the parent POM, project 1, and project 2 even, into Maven local. So when I go back to project 2 and do Maven compile exec Java, it works, Devox France 1. But if I go back to project 1 and say Maven Java sample version this, change version 2, and just happily, I just forgot, no Maven install, and execute project 2 again, what will happen? Aha. See, this is the problem, outdated dependencies. So every time now you're forced to push snapshot dependencies to a repository in order to consume them. Let's see what happens in Gradle. I do a Gradle clean, then switch into project 2. Actually, let's do it again. Clean on the top, then switch into project 2, and do Gradle run. Compiles project 1, compiles project 2. No intermediate repositories, no intermediate dependencies. I go here in project 1, and remember, I'm still in project 2. Do another Gradle run. Compiles project 1, compiles project 2, gets the right result. Change something in the main class. Like this, Devox Friends. Run it again. Notice what happens. Project 1 stays the same. Everything is cached. Project 2 is the only one that changed. Now I got that. And this, my friends, is exactly why I believe Gradle is a better choice for multi-project builds. A few more other things that I can show, but I'm almost running out of time. So, but there are more things that I can tell you. In Maven, how do you initialize a project? Maven archetypes, or copy and pray, right? Gradle doesn't have archetypes, but there's another project called Lazy Bones, which allows you to bootstrap projects in any way that you want. You can bootstrap Gradle projects, Maven projects, and you name it, as long as there's a template for it. And you can also install it using SDK. There is a plugin portal that you can find out there, plugins.gradle.org, where if you need to find if there's already a plugin out there that delivers a behavior that you need, just go there. I have a list of plugins that I have found very useful on my daily work. Don't worry, I will put the slides online so you will be able to get this. All of this, plus a few others, make your life much, much easier. And then you can see shadows somewhere there. I use this plugin a lot. I also tweet on this account, Gradle Plugins, when I find something interesting about Gradle and Gradle plugins, then there you go. So with this, thank you very much. I'm almost out of time. So I thank you very much. Keep enjoying DevOps Friends. If you got any questions, just see me outside of the room. Thank you.